So we just got done creating creating squares two different ways, right? Doing it with the absolute motion, looking at the coordinates in the corners of in the vertices of the squares, and the relative motion, the idea of move, turn, move, turn, move, turn. And I sort of alluded to this earlier. I think that if you're doing simple things like triangles and squares, absolute motion can work really, really well. If you're trying to draw very specific shapes, you can get out graph paper and you can figure it out. But I actually really like relative motion when you're doing more complicated, more advanced polygons. And so I'm actually going to change these around a little bit. I'm going to put this one onto the green flag clicked. We're just going to get rid of this one now. And let's think about how I would change this if instead I wanted to make an octagon, which was my illusion before, right? If I want to make an octagon, and so I come in here and say, clearly an octagon starts by saying I want to have 8 sides, right? So I'm going to say, let's 8 times do my move turn, and so let's see what this looks like, right? We say make an octagon 8 times. Wait a minute, that's not an octagon. That's a square. Ah, see, we've got a problem here. That when you make an octagon, it is 8 sides. This cat did draw out 8 sides, but I have to change my move turn. And in particular, this is where things get a little bit weird when we talk about move turn. I'm in fact going to step back from the octagon and say, suppose we want to make a triangle, because it's going to be easier for me to show you this if we start by making a triangle. So a triangle 3 times, let's move turn. Right? And obviously if I do this now, I'm going to get a square that's missing 1 side because I've only made 3 sides of the square. And we know that to fix this, I have to adjust this turn. And so the question is, well, what do you adjust it to? And if I'm in the classroom and I'm talking with students, whether this is elementary, middle school, or let's face it, even college students, I almost always get an answer of 60 degrees here. Because we've all learned that an equilateral triangle has 60 degrees in the corner. And then you run this, and you notice that that's not even remotely a triangle. How come? And so here's something that we have to look at. And again, this is a little bit confusing at first, but we have to think about what this turn actually means. Let me run this for a second, and let me make the first turn here, right? So I told the cat to go forward 100 steps and then turn. And so when he reached this vertex, this edge here, he was originally pointing 90 degrees. Right? He was actually literally pointing in direction 90. And then we said turn 60 degrees. Well, 90 plus 60 is 150. And if you remember from the motion menu and the idea of turning and pointing in direction, if we point in direction 150, right, that's down and to the right, which is exactly what he's doing right now. Of course, to really make this triangle, I want to actually turn even more than that because I know that I need to come back over in this direction somehow so that he makes this edge that comes here and then comes back up. And so what is that degree turn? The problem is that what we've said is point in he's currently pointing in direction 90 and we need to turn 10 degrees, 20 degrees, or whatever this is, right? And we want to turn some number of degrees. Well, how many is it? Most students get to this through sort of trial and error, and they eventually land on 120 as the distance we need to turn on each of those. And that is correct, it's 120. And you start to look at that and say, well, where did that 120 come from? Well, this is now, for those of you who like math and remember your geometry and that, this is the whole idea of interior and exterior angles. If this interior angle is supposed to be 60, that was what we were actually thinking about when we said turn 60 degrees, is this angle is 60. But then what we need to do is turn through the exterior angle, which is 120. We actually got to cheat a little bit of this when we did the square, because with the square, both the interior and the exterior were 90. And so it didn't matter whether you were thinking about either one of them, it worked right. And so with a square, I can turn 120 degrees, or sorry, with a triangle, I can turn 120 degrees and make that. Now, if I want to go with an octagon, what is that? Well, this might take a little bit to see, but with the octagon, it turns out actually to be 45 degrees. Okay? It turns out to be 45 degrees. And let me show you that that almost works, so let's make it. And so the cat is running around on the stage, and you see that he actually doesn't make an octagon, and it turns out that's not because there's an error with my 45. This is an error that goes back to what we talked about with sprites and scratch and going off the screen. You notice that when he got down to the bottom of the octagon here, he went off the screen a little bit right there. And it turns out that Scratch says, I can't take you all the way as far as you want to go or I'd lose you. And so even though the command wanted him to go down more, Scratch said, nope, not going to do it anymore. And so the easiest way to fix this is just to, in fact, raise the y coordinates. Let's not start in the middle. Let's start up here a little bit. And then he'll stay on the screen and won't disappear at the bottom. And so now we get this nice octagon. Okay? And if I want to do a six-sided figure, a hexagon, 6 sides, it turns out I can do 60 degrees. And you might be saying, oh, where's he coming up with those numbers? I want you to notice something here. Okay? When it was a triangle, it was 3 and 120. When it was a square, it was 4 and 90. When it was a hexagon, it was 6 and 60. When it was an octagon, it was 8 and 45. I want you to take any of those pairs, right? 3 and 120, 4 and 90, 6 and 60, multiply the two numbers together, and you'll notice that you always get 360. The number of degrees in a circle. And that's actually not a fluke. That's not, ironic, or it's legit. That's because if you think about this, when the cat starts his tour around the screen, he starts at 90 degrees. He works his way around, and when he gets back right here, right before he jumps out of the way, if you notice when he gets back to that particular corner, he's back facing 90 degrees. That cat is rotating through a 360 degree turn as he makes any shape he makes, whether it's a square or a triangle or whatever. And so that's where I'm coming up with that number. Okay? One last thing I want to show you that's really kind of cool with all of this then is that you can use this idea of polygons and repetition to make all sorts of shapes. So I can make them bigger or smaller. I could make this maybe a hexagon of maybe only 65 side steps per side. Right? And so that's going to give me a smaller hexagon. I'm going to pull the weight block out so you can see this. And again, I could make it even smaller. I could make it 29 because I meant to type 20, but my finger slipped. But that's okay, 29. Right? And we can do this with any size of thing. So I could say make a 10-sided figure. Let's see, 10, since I want this to be 360 degrees, 360 divided by 10 is 36. 10 times 36 is 360. I can make a decagon, a 10-sided figure. And what you notice pretty quickly is if I wanted to make a circle, the way to think about a circle is it's a 360-sided figure where each time I only turn 1 degree. 360, 1 degree means I'm going to make this circle. It's kind of slow, but I can make a nice circle out of this. And what's really kind of neat about this is if I want different size circles, I can play with this. I can only take a half a step each time. Again, very slow, but you start to see what's going on with things. We got a much smaller circle now. And so while, the idea here is that a circle, even though the mathematicians would cringe at me saying this, a circle is basically a 360-sided figure. It's not. It's an infinite number of sides, or one side, depending on how you look at it from a counting perspective or a polygon perspective. But what's really kind of cool is it turns out that it doesn't really matter that much. So if I put into here, for example, 24 and 15, And let me actually step a little bit bigger here. Let me try steps of 3. So 24 times 15 is 360 degrees. And so with 24 sides, I can get what's still pretty darn close to a circle. Let's go bigger. Let's try 10 on each side. You can hardly tell that's not a circle, even though there's only 24 sides on that polygon. And it goes much quicker because rather than trying to draw 360 sides, you're only drawing a fraction of them. You're drawing 24. And so we're going to use this idea of polygon tracers and polygon shapes in some of our upcoming videos as we move on to our next feature in this unit.